Hi, this is the video for the active filter lab. So to start, we have our breadboard set up here with just an op amp with a 5 and -5 volt connection, DC connections that we get straight from Digilent. So starting with the first step, we have a low pass filter, which we made by connecting one resistor here into power, then another one across the negative input of the op amp and the output, which is also in parallel with the capacitor, and the capacitor is what makes like an active low pass filter. So on the computer here we have our we have the gain and like the frequency sweep for the low pass filter. So what you see is at lower frequencies the gain is very much like at a maximum, like about what we'd expect, but at the higher frequencies over here it basically goes away. There's like a lot of attenuation there, and the phase response is also interesting. You start at around -180, then at around 10 hertz it flips completely to +180, and that will be very relevant later when we combine the two. Okay, so moving on, the second stage is a high pass filter. Setting it up on its own, we have a capacitor and a resistor that run into a power source. So for step 2 in the lab, the power source was just from Digilent. So what you get is just a high pass filter whose gain is proportional to these resistance values here. So the chart for that, for the frequency and phase response, looks something like this, where instead of this time at low frequencies you see a lot of attenuation and really the circuit just doesn't really do what you want, and at high pass filters the gain is at basically a maximum, and then the phase response you see at low frequencies it's kind of all over the place, like not really in phase, but then there's a point here where it goes up and like stops inverting, similar to the last filter. It just, you see it go from like inverting like the phase to like -180 to 180. So the next step was, instead of connecting the capacitor of the second stage straight into the power source, you connect it to the output of the first stage. So what you get when you do that is essentially a combination of the two. So what you see here is that it's literally just a combination. So like the frequency here is around 20 hertz, and over here is around like 20K or so, basically just around when each filter like starts behaving normally. So like for the low pass filter, or high pass even, excuse me, you see around 20 hertz here. That's when the signal starts to look like fairly normal. And similarly, and a similar effect with both filters. And what's really interesting is the phase response here is essentially just like an addition of the two phase responses. So like the high pass and low pass filter, when you just add their phase responses, like when they're -180 and +180, is kind of here in the middle. They just cancel out completely, and you have like an amplitude. So I think that is everything. So thank